Imagine standing in front of one of the most mysterious and fascinating wonders of the universe. I'm talking about black holes. These are structures so dense that not even light, the fastest thing we know, can escape their gravitational pull. It's as if light, in its desperate attempt to escape, ends up trapped forever, in an eternal dance of capture and impossibility. Now, think about it. No matter what you are, a planet or a star, if you get too close to a black hole, forget it. There's no going back. You could even try to resist, but that would be like fighting the inevitable. Once you cross the threshold of a black hole, it's as if you disappear from the rest of the universe, locked in a cell with no windows onto the cosmos. But wait, the story gets even more interesting. Today we're going to talk about something even more mysterious, the yet-to-be-discovered siblings of black holes, white holes. Can you imagine what they might be like? If black holes swallow everything, would white holes be the opposite, expelling matter and energy? How would this be possible, and what would it mean for our understanding of the universe? Can you imagine time travel? No, I'm not talking about science fiction-style time machines, but real travel, based on pure science. What if I told you that it all started with a guy who, despite looking like a character straight out of a rock band with his wild hair, actually changed the world of physics? That guy, my friends, was none other than Albert Einstein. At the dawn of the 20th century, Einstein dropped a bombshell on the world of science, a paper on the theory of restricted relativity that left everyone open-mouthed. And not because it was difficult to read, which, let's be honest, it probably was, but because of its revolutionary idea. Time, that thing we all think we understand, is actually as relative as your aunt's opinion on the best type of birthday cake. So what does the theory of restricted relativity have to do with you, sitting there watching this video? Well, it tells us that time is a kind of cosmic jelly, moldable and not as fixed as we think. If you could run, or fly, who knows, really fast, I mean so fast that it would make Usain Bolt look like he's walking backwards, time would literally slow down for you compared to someone who stayed on the sofa. Now, think about it. While you're standing there, trying to beat the record for how long you can go, without blinking, time is passing differently for someone who's on the move. This not only challenges our notion of time, but also opens up a whole range of questions. Can we really travel in time? And more importantly, if we travel fast enough, can we get back to see what really happened at that party of the century we missed? Now imagine for a moment that you're at one of the greatest magic shows in the universe, and the main magician? Albert Einstein. Yes, the one with the hair that seems to have its own gravity. Until 1915, we were all used to following Newton's rules of gravity, like good students who don't question the teacher. But then Einstein took to the stage and, with a snap of his fingers, changed everything we thought we knew about the universe. He introduced us to the theory of general relativity, which is more like a magic trick than real science. Einstein told us that the universe is not just a space where things happen. No, he went further, saying that this space, which we call space-time, actually bends and curves, and this bending is what we mere mortals feel as gravity. Imagine, gravity is no longer that invisible force that keeps you stuck to the ground. It's actually the universe cosplaying as a waterbed, undulating under the weight of planets and stars. But wait, the story got even more intriguing when a few questions arose. One of them was, how do supermassive objects, like a planet, distort this space fabric we're talking about? Less than a year later, a physicist called Carl Schwarzschild, the unexpected hero of our story, came on the scene and found the key to this question. In fact, he found not just one, but several solutions. However, one of them was so shocking that neither Einstein nor Schwarzschild wanted to believe it. This solution suggested the existence of a point, a singularity, where all our understanding of space-time simply disappears. But here's the intriguing question. How could this be possible? If a black hole swallows everything, where would white holes get the matter to expel it? Some scientists propose that white holes could be the exit of a wormhole, connected to a black hole in another part of the universe. Imagine that, a cosmic entrance and exit, a portal between distant points in space, or perhaps between different universes. Now, hold on to that information because things get even more interesting. This crazy concept of white holes could solve one of the biggest puzzles in modern physics, the paradox of information in black holes. According to the theory, a black hole that swallows information and then evaporates apparently makes that information disappear forever. But what if, in fact, this information was only transported through this space wormhole, emerging somewhere else, perhaps through a white hole? When a star takes its last breath and collapses under its own weight, then we have a black hole. But what about white holes? These are the magicians who disappear from the stage before you've even clapped. They are supposed to appear at a point in space emptier than your math teacher's stock of patience on Monday morning. A perfect vacuum where not a single particle would dare to set foot. But if, by chance, a rebellious particle were to enter the scene, the white hole would tie itself in a knot and become a black hole. Let's hear it for transformation. Then some physicists with imagination to spare started asking themselves, what if the Big Bang was actually a mega white hole? Yes, that's the theory. That maybe, just maybe, we're all the fruit of a cosmic white hole. Have you ever thought about how our brains love to find patterns in everything? Even when we're looking at the clouds and see a dinosaur playing the guitar? Yes, the human mind is fascinating. But what's even more incredible is how, by searching for patterns, even where they don't seem to exist, we can unlock secrets of the universe. Before ending our cosmic journey today, I need to share a little secret with you, one that makes you scratch your head with curiosity. You know those white holes we spent the whole video exploring? Well, I have to confess, so far we don't have any selfies of them to put on the wall. That's right. White holes may be more elusive than we thought, living only in the realm of mathematical equations, like those dream vacations that never get off the ground. But that doesn't mean they're pure fantasy. Remember black holes? Well, they were also like that imaginary friend of science that everyone talked about but no one had ever seen. Until one day, bang, there was the first photo of one posing in space. So, who knows what the future holds, right? But wait a minute. If talking about a white hole is practically saying that we can rewind the tape of the universe, we're bumping up against one of the most serious rules of the cosmos, the second law of thermodynamics. This law is responsible for ensuring that the mess in the universe only gets bigger and not the other way around. To imagine that a white hole could exist is almost like expecting spilled juice to magically return to the glass. And if you know any tricks for doing this, please share them with us. But look, space is vast and mysterious, and if there's one thing science loves, it's a good mystery. White holes, even if they're just a mathematical delusion for now, give us a way to explore and better understand this crazy universe we live in. So that's it, folks. Thank you very much for embarking on this intergalactic journey with me. Don't forget to subscribe to the channel because, believe me, it makes all the difference if we want to continue discovering the secrets of the cosmos together. So, are you ready for the next video? Maybe we'll find a white hole out there together. See you there.